and some tricky but interesting small applications. With Attila, we introduced 3 test design techniques, and now I will speak about action state testing. And finally, I introduced two-phase model-based testing, and this is the key topic in this presentation. So, for me, test automation is not a tool, not a program development, it's a process. The traditional test automation process is just a test execution automation because no test design is involved. And in this case, test cases are added one by one. There are 3 different types to do this. The first is the coded, the second is the codeless, low code or no code, and finally the third is the capture and replay. However, we all know from more than 20 years that capture and replay method is not good because the maintenance cost will be very high. There are several problems when we apply test execution automation in itself. As I mentioned, there is no test design and the code quality remains low, but the bug fix cost remains high. This is because if the bug is detected after the release by the users, then fixing the bug costs much higher. The cost will be much higher, about 10 times higher than if we found it during the testing phase. The next problem is that in-sprint test automation is not possible because usually the application or the feature will be ready at the last but one day, and there is not enough time to implement all the necessary test automation code. You can do test automation with applying page object model or not. If you are using this, then you should write lots of code. If you are not applying page object model, then the solution will not dry. Don't repeat yourself, and the maintenance cost becomes high. Unfortunately, there are obsolete test cases, and if you have some hundreds or even some thousands test cases, then it's very difficult to find and remove the obsolete test cases. So usually you should live with these obsolete test cases during the whole software development life cycle. And finally, there is no test selection criteria, so you don't know when to stop testing, when to stop additional new test cases, and you can have too few or too much test cases in this case. So for me, test automation is test design plus test execution automation. Test design automation can be do different ways, but usually based on models. And that's why we call it model-based testing. There are different types of model-based testing. On the left-hand side, you can see the state chart where the states are involved. In the middle, there is a stateless solution, business process model and notation. And on the right-hand side, there is a textual model, the use cases. But you can do anything. Finally, you will, or the tool will generate or create a graph. And based on this graph, we can select an appropriate test selection criterion. And it depends for the actual risk level. Here, we are applying models because the models are more compact than the code and more compact than a very detailed description, because when we use model, we extract the essential part of the system and we neglect all the unnecessary part, which is not necessary, for example, for the testing. The advantage is that manual testers can be involved into the automation process, and because the test code will be generated from the model, there are no obsolete test cases, because if the requirements are modified and obviously the model is modified, then the test cases are generated from scratch. And therefore, there are no code refactoring and the maintenance cost will be lower. Blow Research made a survey about test design automation, and based on them, test design automation is the ability to automate the entirety of the testing process, starting at an extremely high level. And here is a chart. You can see that lots of companies are doing test design automation and related tools. And here are the champions, the challengers, and the innovators. Unfortunately, my company, Need4Test Plus, is not involved because this chart is a little bit old, 3 years old, I think. But there are problems with traditional model-based testing tools as well. For me, the biggest problem is that models are computer readable, and in this case, it is overly detailed and implementation dependent. For example, on the bottom chart, you can see, for example, that there is an element for press login and so forth. The next problem is that the in-sprint test automation is very difficult because of the method is implementation dependent, and you can do it when the application is ready. You can do it before, but I tried it and unfortunately I should rework almost the whole thing again. The next problem is the infeasible path. If you are using an appropriate test selection criterion, even the most simple, then you should traverse the graph in different ways, and there may be some infeasible steps. For example, if a step is to add the third car into the cart, then the next step to remove the second car is not possible because you should remove all first the third car. To avoid this infeasible path problem, coding is required. We have stateless and stateful model-based testing models, and if you are applying stateless solution, then it probably will not detect the tricky bugs. On the other hand, if we use stateful solution, then sometimes it's difficult to apply, and in some cases the stateless solution would be better. And that's why we realized that we should have a new method. This is the two-phase model-based testing. We realized that models don't need to be computer readable, but models should be only human readable. And this is a big difference because in this case, the model can be much higher. Here is the two-phase MBT. We start from the first phase, which is a high-level model, and it's human readable. And from this, the manual test cases are generated. And from the manual test cases, the tester can execute the test, and during the execution, a low-level model is generated that is machine readable, and we go back to the traditional model when everything is machine readable. And this from this model, we can generate any test automation code, and we can execute the test cases. Here is the first phase. It's the high-level modeling. It consists of actually the test design. It's entirely implementation independent. And here, from the implementation independent model, the abstract test cases are generated. As I mentioned, this can be executed by human, but cannot be executed by a tool. An advantage is that the requirement specification problems can be observed and fixed when you are doing the model, and this is a very good defect prevention tool. Actually, it's much better if you make a model than if you are reading the specification several times. And it's true because we have a small pizza application, and I made the requirements, and I believe that everything is okay. But when I made the model, it occurred that two requirements should be fixed. And finally, the tests can be considered as a contract between product owners and developers, because the test can be considered as examples, and not only as examples, but living examples. And if there is a discrepancy between the specification and the code, then one of the test cases will fail, and you know that the specification and the code is not the same, and you should modify it. So it's very good if an outsource team made the code and there is no debate or quarreling. Just execute the test cases, and that's all. Now, here is the phase 2, where we implement the model. This is the automation step, and test cases are executed manually. And during this manual execution, gherkin-like steps are generated. I will show a demo this. And from this low-level model, gherkin-like model, the test code is generated that can be executed by tool. A huge advantage is that different code can be generated, but currently we generate JavaScript code for Cypress. This method is very fast. Obviously, there are no obsolete tests. And a big advantage is that there is no need to know or calculate the result in advance. It's enough to check. And this is very good because checking the result is much easier than calculating it. And if you have a long test case with, for example, 25 steps, and you make a mistake at the third step, then probably all the subsequent steps will be wrong. Now, and we arrived at to our tool, Harmony, that is a test design plus test code generator tool. And this is the only two-phase model-based testing tool. And it's a genuine codeless test automation tool as well. And it's also a defect prevention tool. But as I mentioned, the test automation should involve two things, test design automation and test execution automation. And we use for test execution automation a very good tool, Cypress. that is a robust tool, and now it's downloaded the most. It overtakes Selenium and has an advantage over Playwright and so forth. And it's really robust. It was tested by the Erste George project with almost 5,000 end-to-end test cases. And currently it's used by 8 million users. And I'm also a user of George, and it's really a very good application. There are several advantages of Cypress, several good features. But I don't want to go through all these things, but there is a very good time traveling feature, so you can watch every executed steps, much less flaky test than by using Selenium and so forth. Okay. And here is the two-phase model-based test automation process. We start from the requirements or the user stories, and from the user stories, we should create high-level model. This is a manual step, and from this model, the manual test cases are generated. This is completely implementation independent. This is the first phase, and during the second phase, the test cases are executed by humans, and a low-level model is generated from which the test cases are also generated and finally executed. The first step is to create the requirements, and the requirements are simple text, and it involves some IDs such as R1, R2, R3, or 1.1, 1.3, and that's all. The next step is the high-level model. We introduced a new test design method, test design technique called action state testing. We need this to have a model that consists of the states only optionally, and which really doesn't require coding and involves the outputs in a good way. And in the model, we have action state model steps, and each step consists of a user action that is obligatory, a system response. This is optional because there is no need to validate after each action, and a special state, a test state, that is also optional. Here is a simple example. The action is add the car to the cart. The response is that one car is in the cart, and the state is that there is no discount yet. Now, the crucial point is the state, because there are problems with state borrowed from software engineering. If you are surfing on the net and ask when a system is stateful, the answer is if a system gives a different output for the same input, depending on its earlier state. However, considering this definition, we have billions of or trillions different states, and it's not good, so states should be determined in a new way. Anyway, if you try to find examples for state transition testing, that is obviously content state, then you will find only 3 or 4 examples. The first is the ATM authentication, the second is switching on and off lamps, and the third is calendar and clock settings. But these are very special systems having very limited number of states, but the real applications consist of much more. So The question is how to handle states. And for me, if a system calculates the output differently for the same action, depending on its earlier state, then after the action finished, we arrived at a new state. So it's different because we have a new state if not only the output is different, but if the calculation is different. And this is a big difference because it's much less. And if there is a new calculation, then this calculation can be wrong. And obviously, you should test it. For example, adding 4 items to the cart one by one, the computation is the same, the output is different, but we go back to the same state. However, if adding the 5th item and getting a price reduction, we have a different output, but also a different calculation. And in this case, we should add another state, and we should test it differently because for me the minimum requirement for a test selection criterion is to cover each transition, each edge in the graph. And if the risk is higher, then you can select a higher level test selection criterion when, for example, each adjacent edges should be traversed. Okay, the actions and responses should be as abstract as possible. For example, here is an abstract one, add item so that the price remains below 10. The tester can do it in different ways. Here is another implementation independent solution, but it's not as abstract. First, we should add an item for 7, then for 2, and it's 9, it's below 10. And finally, here is an implementation-dependent solution. When click on the plus icon next to Pizza Mexicana, then click on the plus icon next to Coke. But this is a wrong solution because actions and responses should be understandable only for testers, but shouldn't be understandable for any automation tool. Action state modeling is really easy. On the left-hand side, you can see 2 steps, and the second step is intended right. And in this case, we have a single test case with 2 steps. On the right-hand side, we have also 2 steps, but the indentation is the same. And in this case, we have 2 test cases with one step. And obviously, we should map the requirements and the model and finally the test cases. And you can see with green, it's a label, and this is this can connect the requirement R1 with this model element. It's an advantage that from the textual state action state model, the tool Harmony can generate the state chart. Obviously, this state chart consists of less information, but it's very good for validation because you can detect if some action is missing. And this graph is also used for choosing a test selection criterion. Here is a simple example for action state modeling. We have a very simple requirement. You should buy for at least 10 euros to pay. And it's obvious that we have only 2 states when paying is not possible. It is the start state and when paying is possible. And here is the first 2 steps. The first is when we buy for less than €9, and the second is when we buy for just €9. And in both cases, we go to the same state when paying is not possible, as you can see on the state chart on the right. And on the bottom, you can see that we have a single test case with 2 steps. Okay, but it's obviously not enough because we haven't involved the second state. And to do this, I inserted a third step when we buy for just €10. And in this case, we arrived the state paying is possible. And we also have a single test with 3 steps. You can see that there are no actions from paying is not possible state, but we should have, because they are missing. And to do this, we involve 2 actions. The first is when we add more items and we remain at the paying is possible state, or we remove some items and we go back to the paying is not possible state. As you can see here, the fourth step is when we add more items, and during the 5th step we remove some steps, but as you can see, it's very abstract. So the tester will do it, but it's not how to do this, how many items should be removed. Okay, so as you can see on the state chart, we are ready, and we also satisfied the boundary value test selection criterion, which requires 4 points and not 2 or 3, as you can read from different textbook and the different blocks. Finally, I modified the model, and you can see that the first and the third step are have the same identification, and in this case we have 2 test cases. However, it's different because here is a missing action, and just want to show you that it's not enough to have enough steps. You should arrange in a way that all the actions are covered. And we have arrived at the second phase. From the high-level model, the low-level model can be generated, and we call this model Gherkin++. It consists of 2 parts. We should have obviously selectors, and we also requires, or we hope if the developers introduce special attributes, and in this case the selector is really simple, such as login name, but Harmony can generate any selector, any CSS selector, as you can see on the button, but in this case the tester should involve a meaningful name, such as Mexicana here. And we have the low-level model, we call it phrases, and a phrase contains the name of the action or the response and some Gherkin++ steps. One step consists of the Gherkin keyword when or then, the selector, a keyword is, and a value or an event. For example, here you can see a step from the abstract model, and considering the action, we have a single test step when car+ button is pressed, and it's just what to read, that we should press the car plus button and that's it. And for the response, the rental price is just 300. Obviously, we should map the Cypress code and the Harmony's commands, and we do this in this way. On the right-hand side, there is the Cypress JavaScript code, and on the left-hand side, the more simple commands, but even you cannot write it because it's automatically generated as well. And now here is a small demo. I start it. First, I start Cypress. Okay, Cypress is opening, and I also select a folder where the test code will be generated, and I press T1. This is the only test case. And now Cypress is running. This is an older version. And you can see on the left-hand side, the action add item so that price remains below 10. To do this, first I should press go shopping, then pizza mexicana, then a Coke, and I press done. And I check that the result is below 10 because it's 9, and I also validate that we cannot pay, and the pay button is non-active. Okay, it's a non-active in the 5th element, and here it is. Okay, and I press done. The next part, when I remove Coke, add the beer, and it's 10, and the next step is ready, and I validate 10, and I also validate that now I could pay because the button is active and done. Okay, it's not enough because I should re-execute the whole thing again. I mean the test case, because it can happen that originally the step-by-step execution is good, but something happened. For example, we should include some weight or some other things, but now it's okay. The test case successfully executed. Okay, it's not. So here is my conclusion. You can see on the right-hand side of the bottom the main goals of the test automation. It was based on a survey from several hundreds test automation engineers and so forth. And the main goal is to improve quality, to make users happy. And Harmony do it because it finds really tricky bugs because of the advanced test design automation technique. The second is to reduce time to market. Harmony is really fast, and it's a genuine don't repeat yourself solution. And finally, a good test automation tool should reduce the software development lifecycle cost, and Harmony requires less work and can find more bugs, and a good defect prevention tool as well. Our experience is that currently the model, an average model, is about 20% of the Cypress code. If we are not using periodic model, if we use, then about 10%. Two-phase model-based testing makes in-sprint test automation really possible, and two-phase MBT I mean, harmony can be used by manual testers, business analysts, obviously, test automation engineers as well, and so everyone. And harmony with Cypress are really very efficient, robust, and stable. And it's very important to emphasize that where Cypress can be used, then harmony can be used as well. Because any code, any Cypress code can be inserted into harmony, and even if there are some tricky things when harmony is not applicable, then Cypress is applicable, and even this part can be inserted into our tool. Okay, that was my presentation. Thank you, and let's try harmony and or test design exercises. Okay, and I'm waiting for your questions. I go back.
Thank you, István. Very interesting presentation. All questions can be submitted into the chat, and Bernard will answer them for you. Bernard, you should have presenter rights, so you should be able to unmute yourself in case you need to. And if you don't want to write into the chat, but rather speak, you can raise your hand with the reactions, and we will unmute you.
Yes, hello, thanks.
So no questions so far. We'll give it a few minutes.
While you are thinking, I am adding that currently harmony is used by some users, and especially ISTQB for its new glossary application that will be ready in the beginning of next year, hopefully.
Okay, first question.
Okay. How does it look?
Yeah, or you can read it if you want.
Okay, it's the same. How does it look like, the maintaining of the test? It is easy or hard? Our experience is that it's easy because it's a dry solution, so you should select only a single action or a single response. For example, today I realized that the ISTQB application has changed, and as a selector has been changed, and I deleted only one phrase, and I do it less than 1 minute. If more changes happen, then maybe I should do the whole test, but usually the tests have lots of steps, and you should consider each step in itself, and it's so you don't need to search in a large code, because just to find the necessary phrase, and you can find the phrase in the model and just fix it.
think we can wait for 2 more minutes in case anyone has any other questions.
So there's one new question. Is there a way to connect to the database in order to get some test data? So actually, if you want to like so have the tests run differently based on what is in the database. I don't know if you mean that. So currently we think that tests should be always the same, not depending on the data in the database. So test data belong to the test model itself, the tests. And so currently we don't have this feature. However, if you want to develop a custom solution, so there's always possibility to change the generated code, parts of the generated code, to generate your own custom test code, and there you can access the database, access whatever kind of services you need. Are there any plans to make it standalone app, or is it only going to be as a web app? Yes, we are really hoping to see it in the near future to use it as a standalone app or IDE extension. It's not. I'm not sure still if it's going to be an app or an extension to IDEs.
Anyway, formerly we had an on-premises version, so if a large company wants to use it, then we can separate from the web.
Yeah. Thank you too.
Thank you.